So yesterday we have started with the post and core, isn't it? Uh, so post and core, all of you know that what is post and core? Post it is a structure which is placed inside the radicular portion or the root, है ना? Inside the radicular portion in order to get more retention to the coronal restorative structure. Okay, so pose it may be metallic or it may be non-metallic. So if it is a metallic, it will have a more rigidity. So there are chances of fracture of root dentin. And if it is non-metallic, it will have a similar modulus of elasticity or equal to like a near to dentin modulus of elasticity. So we prefer non-metallic one. Isn't it? Yesterday we have seen that the classification of post also. So posts are metallic, non-metallic. This is depending upon the structure of which it is made. And post, next classification, it depends upon the shape of the post, like whether it is parallel or whether it is conical shape. Yesterday we have also seen that parallel pose have more retention than the conical pose. But parallel pose has, they create more stresses in root dentin. On the other hand, conical, they are less retentive, but they causes less stresses. Okay, so second classification is, first one is of metallic, non-metallic, second is parallel, or it is depending upon the shape of the pose, whether it is parallel or conical. Yeah. Third one, it is depending upon the surface of the pose, whether it is serrated or whether it is smooth. The smooth one you need to cement with the help of some cementing media inside the root dentin. The other hand, serrated, you have to screw it inside the root dentin. So this is the third classification, which is serrated and smooth. Serrated will cause more stresses, but it will have a more retention. On the other hand, smooth will have a less retention, but it will have a less stresses also. Means it will cause less root chances of root fracture in this cemented one will be less. So retention we can improve with the different luting cement, like the cement which we'll choose, which will bond to the root dentin, like dual cure composite resin, then resin modified GIC, which bond to the tooth structure. So we can choose, if you have given a choice, so you should choose a cemented post and you have to lute it with the sluting area, cement which bond with the root dentin. So retention factor will be overcome to some extent and the stresses are less in case of conical. On the other hand, if the root length is more than sufficient, in that case we choose a parallel course. Okay, so the surrounding root dentin will be more and there will be the less chances of fracture of root, isn't it? So according to condition we have to choose the post. So classification, it is we learn the classification, we learn the advantages and disadvantages so that you can choose the proper post. Suppose metallic, where you will choose the metallic and where you will choose the non-metallic. Non-metallic, in the case where the recently treated tooth, RC treated tooth, it is better you should treat uh, uh, with the metallic one because it will have a less brittleness. On the other hand, if it RC it is treated, the tooth is treated, it is long ago. In that case, the tooth itself it is more brittle than the previous one, and in such cases you have to choose uh, this one only, your non-metallic one. If you have like another case like whether it is aesthetic or a non-aesthetic in posterior, you better choose a non-aesthetic, and if it is anterior one, you have to choose aesthetic. Yesterday we have seen two types of in the aesthetic, whether aesthetic chair बरेचसे टाईप काल आपण पाहिलं. दॅट इज कार्बन फायबर पोस्ट, इट इज अ नॉन एस्थेटिक, then zirconia coated, then composite pose, and different pose. Yesterday we have seen, isn't it? So these are the different types of pose. Today we are going to learn about the core. In pose, another classification is whether it is prefabricated or whether it is casted. If it is a casted, it is known as custom cast pose. This is another classification of pose. So you know different classification of the pose. So today we are going to learn core. So what is a core? Core is the core, it is the coronal structure which we build up on the pose. That is called core. Okay. So once you root or you thread the pores inside the radicular portion of the tooth, then you have to build up the upper coronal structure on
So
the,
no.
you have to pose upper coronal structure on the pores. Okay, so you can build up with the casting also, you can build up with the your routine restorative material, that is amalgam, resin modified GIC, or you can also build up with the composite. Okay, or you can also do it with the casting. Am I clear? So these are the commonly used core material. What is a core material? On the pores, we build up coronal structure of the badly destructed tooth. This is called core. So what are the ideal properties of the core? Means like for amalgam, with whatever things you use for the building up the coronal structure, it should have some properties. So it should have a good compressive strength so that it can bear the masticatory force. It should have a good flexure strength so that it can bear the flexure. All of you know that under mastication our tooth flexes slightly. Okay, so it should have a sufficient flexure strength equal to your dentin. Okay, third one is it should have a good marginal shape. Otherwise, there will be the micro leakage and the secondary carriage. So, how we will get a good marginal cell? The core structure should bond with the remaining two structure. Okay, the important point we are discussing. One is it should have a good compressive strength so that the masticatory forces it will bear. Second thing, it should have a good flexure strength so that it will flex with the remaining two structure. If it is a rigid one, what will happen? It will cause the fracture of surrounding whatever small dentin present in the coronal structure. So we want a structure restorative thing which has a similar flexure strength as that of the dentin. And third one, it should have a good marginal seal. How you will get a good marginal seal? When it will bond to the tooth structure. If it is in an aesthetic area, it should have a good aesthetic properties. It should be, what you say, it should be tooth color. Then all of you know that you should get a proper manipulation time or a working time. Second thing, it should have less absorption property. So water absorption should be less. All of you know that GIC has a water absorption capacity. The hydration continues for some time. That's why uh, it will look open. So similarly, amalgam will have no absorption, water absorption property after setting. So we should choose a core material which has a minimum water absorption property. Similarly, one more thing that it should have a good coefficient of thermal coefficient of expansion. Good means it should have a thermal coefficient of expansion similar to your dentin. Otherwise, what will happen? It will expand on the, if the coefficient of thermal expansion is more, it will expand on a hot thing and it will contract on a taking cold thing. So it should have minimal thermal coefficient of expansion. You just go through by this feature. So just now I discussed that it should have a good compressive strength, it should have a sufficient flexure strength, biocompatibility. So it should be biocompatible with the surrounding oral structure. It should not cause irritation to your mucosa, it should not cause allergic reaction to your mucosa or to your pulpal periapical tissue. This is called biocompatibility. It should cause resistance to leakage, means what? It should not cause micro leakage. Ease of manipulation. We didn't discuss this, but this is a very simple thing. It should be easy to manipulate. I told you that it should bond to the remaining two structure. If it bonds to the remaining two structure, leakage will be less. Just now we discussed that it should have a good thermal coefficient of expansion. Means what? It should not contract or expand on taking hot and cold thing. It should be dimensionally stable. Means what? After you have restored the core, it should be dimensionally stable. It should not change its dimension. Name itself indicates it should be dimensionally stable. It should not be expand. It should not be contract in your mouth. That is dimensionally stability. It should not cause corrosion. It should not cause tarnish. It should not react with the oral fluids. This is called dimensional stability. Minimum potential for water absorption. Just now we discussed if the water absorption is there, what will happen? It will changes its properties and we don't want that. So this is the ideal features of the core material. And one more important thing is it should inhibit the dental caries. So which are the materials which inhibits the dental caries? GIC, polycarboxylate, isn't it? So uh, we don't use GIC because on the other hand we use a resin modified GIC. We also use GIC for the core buildup, but resin modified GIC has more advantages as a core buildup on the GIC. So that's why we prefer resin modified GIC as a core buildup, and it has a ability to inhibit the dental caries. But amalgam composite do not have ability to, they are be used for the core buildup, but they don't have the ability to inhibit the dental caries. Okay, so GIC has a resin modified GIC which we use for the core buildup. It has the ability to inhibit the dental caries. Here is the classification of core material. And thus, this is a metallic core. It is like here. So here, cast core, that is cast metal, and second one is ceramic to zirconia dowels. See, casting it is done of metal and it is done of the ceramic also. Casting सिर्फ metal का नहीं होता है, casting it is also done of the ceramic also. This is done in the direct or indirect method. All of you know that for casting there are two ways which are direct or indirect. Direct we do inside the mouth, indirect we do it in the lab. So core buildup on the pores it is done here on the metal also on the ceramic also. And second thing, it can be done in what you say it sorry it can be done on metal also, it can be done on the ceramic also. This ceramic casting, it is done on the zirconia post. This is done on the zirconia post. This is plastic core material, means this is done directly inside the mouth. This is done in the mouth or outside the mouth, means in the laboratory. This is plastic core material. All of you know. When you place a pose inside the radicular dentine, you cement it inside the radicular dentine, and over this you build up restoration. This is called core. Okay. For core we use amalgam, GIC, resin modified GIC, and dual pure fibers reinforced composite. Okay, dual pure fiber reinforced composite core. Okay, so here the most commonly used is amalgam, and the next most commonly used is dual pure fiber reinforced composite. Then third one is resin modified GIC, and fourth one is GIC. Why it is so? Amalgam has a good compressive flexure strength. It is more biocompatible and it is having a good manipulation, easy to manipulate, and it will have a less, what you say, good coefficient of thermal expansion, less marginal leakage. Next is composite. It has a less marginal leakage, it has the ability to seal with the tooth structure, and it is aesthetic also, and it has a sufficient compressive and flexure strength. Resin modified GSE, similar to your composite core, it bonds to the tooth structure and it has an anti-kerogenic property. So because of this, its compressive strength and flexure strength is less than the composite, but it has a good anti-kerogenic property, and it bonds to the tooth structure, so micro leakage is less. So first common is amalgam, next common is composite, third common is resin modified GRC, and fourth is glass ionomer. Okay. Now, how to prepare a tooth for the post and core? Now you know how to select the post, how to select the core. Okay. And next is how to prepare the tooth. So there's three-stage preparation. Okay. So now you have selected the pose. Now you know which code you have to use. Now how to prepare it. See, post and core, it is done always in a RC treated tooth. As the tooth is badly disrupted, it is already the pulp, it is completely damaged. So first thing, always post and core, it is done in the RC treated tooth. Previously, I told you, you have to take a support of radicular portion. You have to take a support of root. How you are going to take the support of root for the retention? You are going to remove 2/3 of obturation of root. You are going to remove 2/3 length of kataparcha from the root. Suppose the root length which is obturated, it is 15 millimeter. Am I clear? It is 15 millimeter. So 2/3 of 15 is 10. So you will remove GP from the coronal portion of 10 millimeter. First stage is remove the root canal filling material from the coronal 2/3 part. Then prepare the canal. Okay, prepare the 10 millimeter of the canal. This preparation is known as post preparation. And third one is then you have to cement the pores. You have already chosen the pores. Then you have to cement it inside the canal with the help of lutein cement. And next one is you have to build up with the help. The coronal portion you can build up by two procedure. One is direct build up, second is indirect build up. Direct build up it is done with the help of just now I told you with the amalgam, with the GIC, with the resin modified GIC or dual cure composite resin. And indirect method is casting method. Okay. So first thing, we'll do the preparation of canal. Now, just now I told you, you have to prepare this RC treated tooth. So, how you are going to prepare? First, you will remove this GP. So, you will remove this GP 2/3 of length. Okay. So, always for preparation of canal, these are the what you say. You have to remember that conservation of tooth structure. It is the principle of the while preparing this root coronal 2/3 of length. So, remove minimum tooth structure from the canal. See, remember that while removing this GP, you have to see that surrounding denting, surrounding minimum 2 millimeter denting should be there. While preparing this coronal 2/3, I told you you have to remove the GP from the coronal 2/3 of the root. Then you have to prepare the canal with the help of piezoremer or of some buzz which is specified for that post. Okay, so while preparation of the this coronal 2/3 of canal, the principle is you have to conserve the tooth structure. So remove minimal tooth structure from the canal. Once the GP is removed from the canal, you have to prepare the surrounding canal, radicular canal. So while doing this, you have to remove the minimum root dentin from this canal. Okay, what happens if you remove extra tooth structure, or you will weaken this surrounding dentin, and this will lead to the perforation. Okay, if you prepare extra, this will lead to the perforation. So what should be the thickness of surrounding dentin? It should be 2 millimeter. Suppose once you remove the GP, there will be the cavity. So you have to see that surrounding dentin of minimum 2 millimeters should be present. Okay. One more thing you have to remember that cervical ferrule should be always present. What is cervical ferrule? Yesterday I told you cervical ferrule is the metallic band which encircles remaining tooth structure. What is ferrule? It is a metal band. See, it is a See, this is a metal band of the crown. Am I clear? This is the metal band of the crown of the which encircles the remaining coronal portion of the tooth. See, this is the coronal portion of the tooth. Okay, and this is the metallic part of the crown. Okay, this is core and this is the post. This is the coronal portion of the post. This post is in it extends in the root. Here this is pores. Over that we build up the core and this is the ferrule. Ferrule, it is the metallic band of the crown which encircles this remaining coronal structure of the tooth. Okay, this is very necessary. If you don't give ferrule, what will happen? The force is it will cause us more. I told you yesterday the stresses are more in the which area? In the shoulder area, in the CJ junction and in the apical 1/3. So we can reduce the stresses in the CJ area by giving ferrule. Am I clear? Here there is no ferrule, so there is more chances of fracture resist. There is more chances of fracture. So ferrule will increase the fracture resistance. If you give a ferrule, it will cause us less fracture. Chances of fracture will be less. Similarly, this ferrule will prevent rotation of the crown. It will prevent the rotation of the crown. So what are the advantages of ferrule? It will give more fracture resistance, and second thing, it will cause us less rotation. So it will act as an anti-rotational feature. The same thing it is described over here. और यार time खत्म. जाधव, time संपला का? The meeting will end. Upgrade now to remove the protein. Time संपला का?
एक मिनट
आहे ना? ओके ठीक. So sorry. So here, just now I discussed, because of ferrule there is less chances of fracture. Here, ferrule is not there, so it causes rotation, and rotation of this crown, the stresses are transferred to the root dentin and there are chances of fracture of root. So, suppose for giving ferrule sufficient tooth structure is not there. In that case, how you will get the sufficient root crown structure? Suppose to give a ferrule, you need a sufficient crown structure. And if sufficient crown structure is not there, then what you are going to do? You can do it by two ways. One way is the surgical exclusion of the tooth slightly out of it from the socket, or orthodontic exclusion. You can also do with the help of crown learning. Okay, if sufficient coronal structure is not there for giving ferrule, in that case you can do the crown lengthening, you can do the surgical exclusion, you can do the orthodontic exclusion. So for doing this, one more thing is needed, that is the crown root ratio also we have to consider. Minimum, like half part of the root should be there and half part crown portion should be there. Minimum I am telling you. See, you have to consider crown root ratio also before going for orthodontic exclusion, surgical exclusion or for crown lengthening. you have to see that it should have a sufficient crown root ratio. Otherwise, this will fail. It is not like that you will have a more crown structure and a short root. It won't retain, isn't it? So minimum 1:1 ratio of the crown and root you have to follow. Otherwise, you will exclude the root portion, but root will be less. If the root will be less, your post length will be less, and the failure of the post and core will occur. Am I clear? So leverage towards the root will be more and there will be the fracture. Here, these are the cases which have shown that it is in that case, orthodontic extrusion, it is done. Here, before going for this preparation, we'll see how the pores are retained inside the root. What are the things you should consider while placing the pores inside the canal? So, the pores will be retained. Retention of the pores inside the radicular part, it is depends on this four structure: pores length, pores diameter, surface texture, and luting agent. So pores length. First we'll decide the retention of the pores. We are discussing retention of the pores. Pores should get fixed inside the radicular dentine. It should remain in the radicular dentine. It is done. It is depend on the four things. The first one is pores length. More the pores length, the retention will be more. So it doesn't mean that you will give the for the full length. So full length of the root. You have to see that apical 1/3 GP should be intact. Otherwise, what will happen? There will be the leakage. See, here I am telling you the apical GP should remain intact. So it should not cause leakage from the periapical area into the root canal. So this seal is very important. So how is the seal? For if it is a 5 millimeter, then only this seal will be good. So what should be the length of the pores? Length of the pores should be 2/3 of the length of the root. Okay, suppose this is a 15 millimeter, then 10 millimeter will be the pores length. Okay, 10 millimeter will be the pores length, and this 5 millimeter should be there so that the seal will remain intact. This periapical, this apical foramina seal with the GP should be always intact. Okay, am I clear? So what should be the length of the pores? Pores length should be 2/3 of the root length. Provided that, suppose now I have a very small root. In that case, if I have a length of only you say 9 millimeter. Okay. Now I told you, just now I told you the GP should be, to have a good apical seal, minimum 5 millimeter GP it is necessary. Okay, minimum 5 millimeter GP it is necessary. Now the root length is very small, it is 9 millimeter only. So we have prepared a 6 millimeter post length post preparation, and here only 3 millimeter will be there for the seal. So seal will be compromised. Here the seal will be compromised. Never ever the seal should not be less than 3 millimeter. It should not be less than 3 millimeter. Ideal seal is of 5 millimeter. Am I clear? Ideal apical seal should be 5 millimeter. If it is less than that, 3 millimeter, it is a compromise. And after 3 millimeter, it is of no use. Okay. So length should be 2/3 of the root length. Next is post diameter. Just now I told you the post diameter should be great. More the post diameter, more will be the retention. And I just told you that you have to conserve the surrounding root dentin. So surrounding dentin कितना रहना चाहिए? See here. It should be 2 millimeters surrounding dentin should be present after preparation of the pore space. After preparation of the pore space, there should be 2 millimeter surrounding dentin should be present. Okay. Here it should be 2 millimeter. After here it should be 2 millimeter. Or you can say it should be, the pores should not be more than 1/3 uh, 1/3 of the diameter of the root. Okay, means this is the, what is the radius of the root. So if it is this, so it should not be more than 1/3 of the diameter of the root. This is, suppose this is 15 millimeter, the pores diameter should not be more than 5 millimeter. Am I clear? The pores diameter should not be 1/3 of the, more than the 1/3 of the root diameter. You follow one of this principle. At one is 2 millimeter surrounding density should be like this. 2 millimeter should be there. There should be 2 millimeter. Here should be 2 millimeter. Here should be 2 millimeter. Or you should follow another principle, that the pores diameter. This is the diameter of the pores. It should not be more than the 1/3 of the diameter of the this root. Suppose the root diameter is 15, then 1/3 is 5. So pores diameter should not be more than 5 millimeter. Okay. Next is pore surface structure. This we have already discussed. Pore surface structure, they are smooth or they are serrated. We have discussed that serrated have a more retention than the smooth one. The control grooving of the pores, it is given on the smooth one to increase the retention and to reduce the stresses. Okay, this is the advanced form of the pores. Okay, but in your syllabus, just remember that if it is a smooth one, it will have a less retention. Serrated will have a more retention, but serrated will cause more stresses and smooth one will cause less stresses. Okay, then the retention of the pores. This pores, it is retained inside the canal on the with the help of luting agent also. Traditionally, we is using GIC. So nowadays we are using adhesive resin cements. We are using dual cure or we are using self cure luting cement. Okay. Before luting, you have to do the two precautions. One is irrigate the root canal with the help of ethanol. Why you have to irrigate the root canal with the ethanol? See, almost all we are using sealer. Okay, sealer, it is the cement which we are using uh, in the obturation. And here we have removed the obturating material, that is GP and this ZOE based cement. Okay, now this sealant, they penetrate inside the dentinal tubules also, which we cannot see with the naked eyes. So if you irrigate with the ethanol, what will happen? Ethanol will dissolve the cement inside the dentinal tubules, and whatever luting agent, suppose you are using